Alright, so in this problem, I have 3 to the power of x plus 3 to the power of x plus 3 to the power of x is equal to 333. So, the first thing I'm going to do is factor out 3 to the power of x from my left-hand side. So now I have 3 to the power of x times 1 plus 1 plus 1 is equal to 333. Now, I'm going to solve what's in my parentheses. So I have 1 plus 1 plus 1, that's equal to 3. So now I get 3 to the power of x times 3 is equal to 333. Now, we want to isolate 3 to the power of x here. And the way to do that is to get rid of this times 3. So I'm going to get rid of this times 3 by moving it to the right-hand side, and I'm going to do that by dividing both sides by 3. So now I get 3 to the power of x 3 to the power of x is equal to 111. Now, if I take the log on both sides, I get log 3 to the power of x is equal to log 111. Now, if I have something in the form log a to the power of b, I can move this exponent b to the front. So it's going to equal b times log a. So in this case, I have log 3 to the power of x, and I can move x to the front. So I get x times log 3 is equal to log 111. Now if I divide both sides by log 3, these two cancel out, and I get x is equal to log 111 over log 3. Now, I can write my solution in two ways. The first of which is to actually divide log 111 by log 3. So log 111 divided by log 3, this is equal to 4.29. So this is one way I can write my solution. Now another way I can do this is if I have something in the form log a over log b, this is going to equal log base b of a. So this is another way of writing my solution. Alright, so in this problem, I have 3 to the power of x times 5 to the power of x squared is equal to 15. So to solve this, I'm going to first start by rewriting 15 as 3 times 5. So now I have 3 to the power of x times 5x squared, 5 to the power of x squared is equal to 3 times 5. Now, I'm going to divide both sides by 3 to the power of x, as well as 5. So then, for my left-hand side, both the 3 to the power of x's cancel out. For my right-hand side, both the 5's cancel out. So now I get 5 to the power of x squared over 5 is equal to 3 over 3 to the power of x. Now, if I have something in the form 1 over a, this is the same thing as a to the power of negative 1. So 5 to the power of x squared over 5, that's the same thing as 5 to the power of x squared times 5 to the power of negative 1. And now this is equal to 3 times 3 to the power of negative x. Now, if I have something in the form a to the power of m times a to the power of n, this is equal to a to the power of m plus n. So, in this case, I get 5 to the power of x squared minus 1. And now this is equal to 3 to the power of 1 minus x. Now, if I take the log on both sides, I get log 5 to the power of x squared minus 1 is equal to log 3 to the power of 1 minus x. And if I have something in the form log a to the power b, I can move this exponent b to the front, so it's going to equal b times log a. So in this case, I get x squared minus 1 times log 5 is equal to 1 minus x times log 3. And now I'm going to take base 5 on both sides of both logs, so these cancel out to get 1. So now I have x squared minus 1 is equal to 1 minus x times log base 5 of 3. And this means that x squared minus 1 plus x minus 1 times log base 5 of 3 is equal to 0. And this gets me to x minus 1 times x plus 1 plus log base 5 of 3 is equal to 0, meaning this is one equation, x minus 1 equals 0, meaning x is equal to 1, and if you solve this, you get x is equal to negative log base 5 of 15. Alright, so in this problem, I have a to the power of 3 plus a squared is equal to 80. So to solve this, I'm going to first start by subtracting 80 on both sides. So I get a to the power of 3 plus a squared minus 80 is equal to 0. Now I'm going to rewrite this as a to the power of 3 plus a squared minus 64 minus 16 is equal to 0. So I simply wrote negative 80 as negative 64 minus 16. And now, negative 64, I'm going to rewrite that as negative 4 to the power of 3. So I have a to the power of 3 minus 4 to the power of 3 plus a squared minus 16, I'm going to rewrite as 4 squared. Now, if I have something in the form a to the power of 3 minus b to the power of 3, this is going to equal a minus b times a squared plus ab plus b squared. And if I have something in the form a squared minus b squared, this is equal to a plus b times a minus b. So in this case, if by using these two properties, I'm going to end up with a minus 4 times a squared plus 4a plus 16 plus a plus 4 is equal to 0. And this simplifies to a minus 4 times a squared plus 5a plus 20 is equal to 0. So now this gives me two equations. I get a minus 4 is equal to 0, and a squared plus 5a plus 20 is equal to 0. So for a minus 4 equals 0, a is obviously equal to 4. And for a squared plus 5a plus 20 equals 0, I'm going to use the quadratic formula, but I'm actually not going to waste your guys' time by actually doing it. So if you do end up doing it, you get that a is equal to negative 5 plus or minus the square root of 55i over 2. And the reason, actually what you should get is a equals negative 5 plus or minus the square root of negative 55 over 2. And the square root of negative 55, I can rewrite that as the square root of 55 times the square root of negative 1. And if you guys already didn't know, the square root of negative 1 is equal to the imaginary number I. So if I replace I with the square root of negative 1, I get a is equal to negative 5 plus or minus the square root of 55 I over 2. So that's how I got square root of 55i.